Hi, this week we'll talk about anaerobic digestion technologies and their practical operation. Remember that you can download the book for free from our webpage if you want more detailed information on anaerobic digestion. This diagram looks really scary, but don't worry, it isn't. It's a classification of different types of AD technologies. We can differentiate between dry and wet systems, between batch and continuous systems, between thermophilic and mesophilic operating systems, and between one-stage and multi-stage technologies. What I would like to go through together with you in this module is we'd like to look at wet, continuous, mesophilic, and one-stage reactors. The examples that we'll be discussing are floating drum, fixed dome, and balloon-type digesters. Continuous actually means that we're feeding at a regular interval at the same time an equivalent volume that enters, an equivalent volume will also leave the digester. Wet means that we'll be operating with a total solid content of 16% or less, so low TS. So now let's look at these digesters. Let me start by showing you the wet, continuous, mesophilic, fixed dome reactor. This is a brick-built and gas-tight plastered structure, which is often put underground. It has an inlet pipe where the waste material is fed into the digester. It has a digester with a volume of slurry, and then it has a gas holder storage space. What it further has is an outlet, or what we also call compensation chamber, and the overflow. You might also see here that the gas pipe is at the highest point with a valve to open or close the gas flow. There are different designs of fixed dome digesters, and sizes can vary. This is the most common reactor type in developing countries. When starting the reactor for the first time, it is important to inoculate the reactor with methanogens bacteria. The easiest way to do this is by adding cow manure and water with a ratio of 1:1, or even easier, use digestate from another reactor. A rule of thumb is that it needs about 10% of the reactor volume as cow manure to start the process. But more is also fine, or even better. In this animation, we can see how this works. The waste material is mixed with water and enters the reactor and mixes with the material already in the reactor undergoing degradation. Biogas is generated in the slurry through anaerobic digestion. The gas bubbles then move to the top part of the reactor, where gas accumulates and starts to build up pressure if the valve is closed. When the valve is closed, the gas pressure will increase and push down the slurry in the reactor and up into the overflow chamber. When then the gas is used, the gas pressure drops and the slurry level balances out to a new equilibrium. Here you see a sequence of pictures of the construction of a fixed dome reactor in Lesotho during the building of the structure and the dome. Here the dome is just about finished. And here it's being plastered. This is another example from Indonesia. What you see here is that the bottom part is built with concrete and the dome part is just starting to be built with bricks. Here is a summary of some advantages and some disadvantages. For the advantages, let me highlight 3. Long lifespan, absence of moving parts, and the underground construction, which saves space. There are also disadvantages. I'll also highlight a few. One is that it needs specific technical skills. It also needs a special sealant to make sure that it's gas tight. And another disadvantage is the fluctuating gas pressure depending on the volume of the stored gas and its use. A second type is the floating drum digester. You see this in this picture. It has similar features: the inlet, the digester for the slurry, the outlet, and the overflow. But here now, the gas holder is not a fixed unit, but is a moving unit. Here it's floating on a water jacket. In some cases, it could also be floating directly on the slurry. With increasing gas pressure, this floating gas holder moves upwards, and when gas is used, the weight of the drum pushes it back down. The gas drum is typically made of metal, painted to protect it from corrosion. It can also be made out of fiberglass, reinforced plastic, or galvanized sheet metal. In this design, there's also a guiding pole to make sure to stabilize it while it's going up and down. There's also a divider wall, which helps to avoid short-circuiting of the slurry from the inlet to the outlet. You see it here. The digester is often placed below the ground, while the gas holder drum is above ground. Here is an example of such floating drum digesters from India, with the metal floating gas holders. Or here another, also from India. Here are examples of small household units made out of fiberglass reinforced plastic. The brown part on the top is the floating drum. Or here another example from Tanzania, made by using the typical water tanks out of plastic and some plastic piping. Here are some advantages and disadvantages of the floating drum reactors. Advantages are that it's simple and easy to operate. One big advantage is that the volume of gas is directly visible, and that means we know if the system is working or not. We also have constant gas pressure, or we can increase this pressure by adding some weight onto the gas holder tank. Some disadvantages are the high material costs for the steel drum, and that these steel parts are susceptible to corrosion. There are also regular maintenance costs that arise from keeping this corrosion at bay. The third digester type I would like to show you is the tubular digester, like this one in Costa Rica. These are quite common in the Latin American region. These are long, horizontal lying tubes or balloons made out of plastic and rubber. The inlet and outlet are attached directly to the skin of the balloon. You see this here in a schematic. The balloon, the inlet and the outlet, and the gas pipe on the top. These balloons usually need some protection from the top as well as from the bottom. What we usually have is a compacted backfill. Some advantages are low construction costs, very simple to install, easy to construct, but some disadvantages are a relative short lifespan and susceptible to mechanical damage. So, those were the three types of technologies that I wanted to share with you. There are a lot of variations in design. For instance, this combination of a fixed structure for the digestate and then a balloon for the gas storage. This is an example from Germany. Why don't you share with us what kind of systems you might have encountered in your region or during your travels? Submit them into our forum. So let me summarize what we covered in this module. We looked at 3 different types of digesters. We looked at their design features and some examples. For each, we listed some advantages and disadvantages. In the next module, we'll focus on maintaining the digester in operation and at the product chain, the gas and the digestate. Thanks very much.